Section 1.2 Atmospheric Layers. The layers of the atmosphere are broken up according to how temperature changes with height. So as we go up from the ground, we have the air occupying the space above it. Now the air isn't the same throughout. As we go up in the atmosphere, it changes. Now most of the air is found at the bottom of the atmosphere. Like 80% of the atmosphere is found in the bottom layer. So we identify the layers of the atmosphere by how temperature changes with height. In the bottom layer, temperature decreases as you go up. Higher you go, the colder it gets. Eventually, at some point above the atmosphere, that will switch. And then as you go up from that point on, the temperature will go up as you go up. Now, this is because of different heat sources. At the bottom of the atmosphere, the ground is heating up the air. And higher up in the atmosphere, we have the ozone layer, which heats it up. And then as you get farther away from the ground, it gets cold. But soon you start getting close to the ozone layer, and then it gets warm again. And as you go away from the ozone layer, it gets cold. So it's all about how temperature changes with height that we divide up the atmosphere into different layers. Now, occasionally we have these kind of pauses. So the pauses here. And they separate the layers. And the pauses are where either the temperature switches direction. So it was decreasing, now it's increasing. Or where the temperature stays constant. Now this is a nice little graph showing you different layers of the atmosphere. It's not really to scale very well, but it can show you a couple things. First off, on the bottom here is temperature in degrees Celsius. We'll just put a little degree symbol. So as we go up in the troposphere is the bottom layer of the atmosphere. This is where you live. You live in the troposphere. As we go up, you see the temperature goes down. So as we go up in the atmosphere, as our altitude gets greater, our temperature decreases until it hits a little spot where it kind of stays constant. You see, as we go up, it's the same temperature, and that's the tropopause. That separates the two layers. And so after we leave the tropopause, we see temperature increases. So you see it's getting greater as you go up. And now we're in the stratosphere. So stratosphere is the second layer of the atmosphere. And then we hit another little pause here. You can see how it just stays constant. And then it decreases as we go higher. Well, that's the mesosphere. And then eventually we get to the mesopause and then the thermosphere where it gets warmer again. Now actually that thermosphere is a little misleading because even though the temperature goes up, it's actually still too cold for you to exist up there. So again, temperature changes with height is how we identify the layers. Bottom layers are troposphere, then the stratosphere, then the mesosphere, then the thermosphere. So tropo, strato, meso, thermo. It decreases with height, it increases with height, it decreases with height, and it increases with height, the temperature. So it changes, and that's how we know we switch layer. Now I know over here you can see a little altitude, the distance one, but the thing is that changes from place to place, from day to day. It can change throughout a day with that boundary layer. So we don't really look at the height that's about an average. We look at how temperature changes with height. Again, here's a little kind of zoom in. Troposphere, temperature goes down as we go up, then it stays constant. That's when we're in the little pause here. The pauses are always named for the layer below it. So we go troposphere and then the tropopause. Then the stratosphere, and then eventually we'll get to the stratopause when it stays constant there. Alright. Again, layers of the atmosphere from ground up: troposphere, stratosphere, mesosphere, thermosphere, exosphere. Now, of course, between the tropo and strato is the tropopause. Between the stratosphere and the mesosphere is the stratopause. Between the mesosphere and the thermosphere is the mesopause. And the exosphere is kind of the outside of the atmosphere. Now, the stratosphere also contains the ozone layer, which plays a very vital role to life on Earth, and it heats up part of the stratosphere, the upper part. So the ground is at the bottom of the troposphere, and the ozone layer is at the top of the stratosphere. Now we can use radiosongs, which is just a fancy word for weather balloon, to record temperature as you go up in the atmosphere. This allows us then to figure out how high the different layers are. It also allows us then to tell how stable or unstable the air masses are, which can really help us in predicting the weather. So the troposphere, the bottom layer, it's the lowest layer, it's also the densest layer, which means that the molecules are closer together at the bottom. We talked about this in the first lecture video, is that as you go up, the air pressure decreases and the density decreases. Well, it means at the bottom, so it'd be densest layer, All life lives in troposphere. It's heated from the ground up, so temperature decreases the height. So again, ground here, and as we go higher up, the temperature decreases. It's about from 0 to 13 kilometers above the surface, and again, that changes, so that's kind of an average. And most weather occurs here. Only the most extreme tops of the clouds, especially what we call a cumulonimbus cloud, a thunderstorm cloud, will reach up into the stratosphere. The rest of the clouds pretty much all occur in the troposphere. So the second layer is stratosphere. It contains the ozone layer. Ozone layer is at the top of the stratosphere. So let me kind of draw here. So down here we have the troposphere, and then we have the stratosphere, and then at the top of the stratosphere, up there is where we find the ozone layer. Now, the ozone layer is not a layer of the atmosphere. Instead, it is just an area where we have a high concentration of ozone. Now, ozone is very important because as ultraviolet radiation comes in from the sun, it is absorbed by the ozone. The ozone breaks up into oxygen and atoms and oxygen molecules, and then they recombine and they do that again. Because of that, because the ozone layer is absorbing all the ultraviolet radiation, it's a heat source. And so as you get closer and closer to it, you're going to get warmer and warmer. So temperature increases with height in the stratosphere because of the ozone layer. About 13 to 50 kilometers above the surface. So it's about 3 times thicker than the troposphere, but it contains a lot less mass because density decreases. Above the stratosphere is the mesosphere. Meso means middle, and that's actually something that helps you understand a lot of the words we use this year. Meso means middle. Some of the coldest temperatures in the atmosphere occur in the mesosphere. Temperature decreases the height because we get away from the ozone layer. We're going higher and higher up, and we get farther away from the ozone layer. It's about 50 to 85 kilometers above the surface, about the same thickness as the stratosphere. Interesting thing is that up in the mesosphere is where the molecules of the air get close enough and dense enough that meteors actually burn up here. So as a meteor, which is just a rock from space, enters this, it encounters all those molecules, all those atoms, and friction causes it to heat up and produce light, and that light we see is what we call a shooting star. Um, Imagine it like this. Imagine on a slip and slide that's all wet, and you're sliding on it, and then all of a sudden it stops and you have a gravel road. Now that's what happens for a meteor as it goes from space into our atmosphere. Nice smooth ride, not running into anything. Then all of a sudden there's all this stuff there, it all have friction, it burns up, and then we see all that light produced. It's just a piece of rock, and most meteors are like dusts of grain or sand. It's very small. Above the mesosphere, the fourth layer, and sometimes the last layer, some people view it, is the thermosphere. Now, temperature increases the height. The highest temperatures are located here. Now, here's the thing: the temperature is not just how hot or cold something is; it's about motion. It is a measure of the motion of the atoms. And so, even though it's the highest temperatures, because there's so few molecules there, there's very little energy overall. And because of that, you would freeze to death up there. I mean, it may be a high temperature, but because there's so little energy, you would actually freeze. It's about from 85 to 609 kilometers above the surface. Obviously, the thickest layer as far as height goes. It contains the ionosphere, which is very important because it's an area of charged particles. So the ionosphere is an area of charged particles. There we go. And what they do is that they can, first off, they're responsible for the northern lights because solar particles, stuff from the sun, travels through space and it enters our atmosphere, interacts with the ionosphere, and it produces northern lights. Another term we use for it is aurora borealis. Another thing that it does is it reflects radio signals. And so at night, typically the ionosphere actually gets higher up in the atmosphere. And so radio signals can bounce off of it and actually travel farther. So this sometimes, if you notice, you get radio station clearer at night. It's actually because the ionosphere is higher up in the atmosphere. So the thermosphere, molecules are very far apart here. It's the lowest density. Temperature actually will record high because each molecule will be moving a lot, but they're just very far apart. It contains the ionosphere. The last layer is called the exosphere. It's the highest layer, often considered the upper part of the thermosphere. So not as a separate layer. It's just where we kind of as the boundary into space.